we'll learn about limiting reactant. Now, as we know, limiting reactant, limiting reactant itself means the the reactant which is limiting the reaction. Suppose we have a reaction of type A plus 2B gives product, and suppose it has initially 5 moles and it has B has 10 moles. After completion of reaction, it will have suppose it is and suppose it has 5 moles and it has 10 moles. Then after completion of reaction, this will be 0 and 10 minus 5 into 2, which is also 0. So both cases 0 and 0, we can choose any one as the limiting reactant and define the conversion of that species. Now suppose in case 2A plus 2B product has 3 moles and B has 10 moles. Now after completion of reaction, it will be 0 and B will be remaining 10 minus 3 into 2, which is equals to 4 moles. Now if we choose in this case B as and calculate B, suppose we choose B as conversion, then if we use the same uh, formula or by using B, we calculate the value of A, we will get a negative value of A. That after suppose B is totally consumed, then we will get the negative value of A. And this will be very much like it will give totally absurd and wrong answers to all the chemical reaction engineering RCRE problems or any stoichiometry related problem. So in this case, we cannot choose B as a we cannot choose we cannot choose this is B as the conversion of B. We cannot calculate any other things. If we do that, then we will be in problem. We can take example. Suppose we choose conversion of B as it's B. Then after NB will be initial moles, initial 1 minus XB. Generally, it will be the case. Like in general, we know that Na will be Na naught 1 minus Xa. Sorry, 1 minus Xa. Similarly, we write Nb as 10 into 1 minus Xb. Now, what will be the Na? Na will be 3 minus. Now, it will go to 3 minus. This is going 10, 10 minus 10. 10 xb it is going. So, it will go half 3 minus 5xb. It will go 5xb. Now, for xb is equals to 1. Xb is equals to 1 means total conversion is 1. We get Na as minus 2. So this is wrong. This consideration is wrong. So hence we cannot choose B as a limiting reactant. Now, if I will in this we will derive how to find limiting reactant. Now to get limiting reactant, suppose we have again a reaction. In this case, we are considering limiting reactant, right? So we will write a reaction which is written like this. Suppose alpha 1 A1 plus alpha 2 A2, or better to write in more standard notation so that it can be used mu 1 A1 plus mu 2 A2 plus mu 3 A3. Suppose all many reaction species are there and this gives product. Okay. Now suppose when these new I are stoichiometric coefficient. New I are stoichiometric coefficient. Stoichiometry. Course. Now suppose I assume that A2 is limiting reactant. Assume that. Assume. Now if A2 is limiting reactant, then Ni. I is the species moles of ith component like one, 2, 3, 4 for ith component. Ni naught minus mu I epsilon. This is Ni. I represent the species moles of species of ith component like A1, A2. If it is N1, then A1. I naught represent the initial moles, whatever it is present. Nu I is the corresponding stoichiometry, and this quantity is known as extent of reaction as we have discussed earlier. Now I have assumed that 2 is the limiting reactant. So if 2 is the limiting reactant, then N2 is equals to N2 naught minus mu 2 epsilon. If 2 is limiting reactant, then this at after total combustion or completion of the reaction, A2 will be 0. So this will be 0. Okay, so from this we get that epsilon value is equals to N2 naught divided by mu 2. Do not confuse it with N20. This is N2 naught. Okay, now as we have seen in this case, the limiting reactant goes first, but still other species will be there. Some value or some modes will be there. Now we will use this logic to find, suppose Nj. J is some different species which is not 2. Nj naught minus mu j epsilon which is greater than 0. J naught equals to 2. So this is not species 2. It will have some value because this species J species is not fully consumed because the species 2, if it is limiting reaction, it will vanish. So there is nothing to react with. So Nj will be present in some quantity. Now, if we rearrange this linear inequality and write Nj naught by nu j is greater than epsilon. Wait 1 minute, this is nu j, this is j. Now we know the epsilon value is, 1 minute, epsilon value is N2 naught divided by nu 2. So we get an interesting inequality. The inequality is Nj naught divided by nu j will always be greater than N2 naught by nu 2, where j naught equals to 2. Now, if 2 is the limiting reactant, then from all the j values, j is means 1, 2, 3, all the j species, this ratio, this N2 naught by nu 2 or Nj naught by nu j will be minimum. So, for finding limiting reactant, we can use that initial moles divided by its stoichiometric coefficient. Whichever quantity gives minimum, that quantity I is the limiting reactant. In the previous case, we have like in our previous case, A plus 2B gives product. It has 3 moles and it has 10 moles. Now, if you do this technique, 3 divided by 1 and 10 divided by 10 divided by 2, then we get the limiting reactant as 3 divided 1 by 1 gives 3 and 10 divided by 2 gives 5. So in this case, the limiting reactant would be, this is the minimum. So limiting reactant would be A. Limiting reactant would be A. Similarly, if you see in any case where the there in if the, where it is mentioned that this is the initial mole and reactions is known, then you can directly find the limiting reactant by finding the in ratio of initial moles divided by stoichiometric coefficient. Whichever is small, that species will be limiting reactant and take that as a reference value. Like if you want to calculate the conversion, take that as conversion XA. Then you will not have any issues or you will not face any error where the moles of any species is coming negative. So for finding limiting reactant, find minimum initial mole, initial mole of species I divided by stoichiometric of species I. Now whichever find I such that this quantity is minimum, that I species will be the limiting reactant. So hope this information is very much useful for you. So we will meet in the next video. Thank you.